Hey, it's Miss Hochstetter here talking about the Unit 2 Kinematics unit and what you need to know for our exam coming up. So this is the cover page of the guided notes, and on it you'll notice there are these essential questions. So you should be able to answer all of these essential questions in your own words and understand what the content is for all of them. So to help you, I'm going to kind of break this down into a few different things. So from this lesson to lesson 4, this is mostly about constant velocity. That's where we look at the constant velocity part of the unit. Then after that, we start talking about acceleration and graphs. So pretty much from here to here, it is constant acceleration, comparing and contrasting that to constant velocity, but also how to look at the graphs. Okay, so that's the kind of the second piece. Then I consider from lesson 12 to 14, that's kind of an extension of that, and that is going to be using equations and math to solve. So that's just kind of your word problem types of questions. And finally, this last section, this is all the chapter 5 content on projectile motion. So basically from here to here, this is all chapter 4. And then there's a little bit of chapter 5 we do right at the end. Now, the equations you're going to need to know. You're going to need to know how to calculate velocity. You're going to need to know how to calculate acceleration. There's those 3 kinematic equations that we use in the reference table, and then those 2D vector quantities for horizontal and vertical components. There's going to be 5 total equations that you're going to need to know how to use, and you'll probably have a question on every single equation on the test. So just make sure you know how to do those, how to solve for them, etc. So that's kind of how I would break down this unit. So if you know that there's a specific area you need to work on, whether it's, either solving equations or doing the constant acceleration or the graphing, I would focus on that part. So now what I'm going to do is I'm going to kind of scroll through the notes and kind of bring to your attention some of the key things that you might need to know. Oh, yes, vocabulary. So in the notes I made a vocabulary list. These are all the vocab words that you have learned in this unit. You should be familiar with all of them. But starting off with vectors, scalars, and magnitude. These are all words you should know. A vector quantity has magnitude, which is size, and direction, where a scalar quantity only has size. You will probably get a question on the test asking you to identify one of those. You should know the difference between distance and displacement. Distance is a scalar quantity referring to how much ground is covered, whereas displacement is a vector that says how far out of place the object is. So how much is changed. And then in the rest of that lesson, we did a bunch of practice problems for that. If I ask you to draw a vector, a displacement vector, and find the resultant, you should be able to do that. There's these practice problems here that we did. Then we start talking about the difference between speed and velocity. They are very similar, very closely related. The only difference is velocity is a vector, which includes a direction. Instantaneous speed and average speed. Instantaneous is the speed at any instant in time, whereas average speed is over a period of time. So then we did several practice problems relating to that. We found an equation in the reference table. That's our first equation. This is the first equation you need to know, and you don't need to memorize the equation, you just need to be able to find it in the reference table and use it. And these are some example problems that you might have to answer on the test similar to that. Then after that, we get right into graphing. So the first graph we focus on is distance versus time graphs. So we had a focus on this, and we spent a lot of time on this. Also, the idea of slope. Remember, the slope of a distance time graph gives you velocity. Oh, the talking points. I love a good talking point. I'm probably going to put one of these talking points on the test as in the form of a true-false equation. So this could be a graph, I'll probably give you a graph. Maybe it'll be this graph, maybe it'll be a different graph, and just ask you different things about that. So this would be a really good thing for you to kind of spend some time on, especially if you don't remember. We talked about the importance of slope. This would give you a positive velocity, this would give you a negative velocity, and this is, of course, a constant velocity, a horizontal line. I asked you to analyze different graph motions and describe what's going on. We talked about slope some more, and then how to make velocity graphs from position graphs. And there were some Regents questions. Okay, then we get to motion maps. I'm not going to ask a motion map question, but I think motion maps are really helpful for your understanding. So instead of giving you a motion map, what I'm probably going to do is I'm going to give you a graph like this. And I won't ask you to make the motion map, but I will ask you to describe the motion in words. So if the motion map method helps you, you can use that. Otherwise, you just need to be able to know how to interpret something like that. And we did a few practice problems with this. Oh, here's another good position graph that maybe I might use for true-false questions. It would be a good idea to know how to read graphs like these to answer questions. Right, moving right along. Oh yeah, more graphing. Making sure you know how to read those distance time graphs. Okay, and then we get to lesson 5, and boom, we're on to acceleration. So that marks the end of the constant velocity learning process. And now that we're in acceleration, you at this point should be able to differentiate between the two. So the equation in that reference table, again, you don't need to memorize it, but it's in your reference table, is change in velocity over time. Deriving units, you need to know that acceleration has meters per second squared. And oh, this is a really good question. Why does the unit of time enter twice in the unit of acceleration? So not only have you seen this question in the notes, and I made you say it like 3 times out loud in class, this question has probably also shown up on a homework quiz, maybe even multiple times. So make sure you know how to do this question, because if I had to guess, at least somebody somewhere is going to get it on the unit test. More examples of what acceleration is. Oh yes, good multiple choice and solving questions. There will be a question on the test that you will have to use that equation for, so make sure you know how to do that. Right, then we started comparing constant velocity and acceleration. So this again is a big key piece, that quiz, the first quiz of this unit. A lot of that quiz was focused on this idea that I highlighted here. So this idea of constant velocity, where the motion map's constant acceleration, where it's speeding up. So you need to be able to know what the difference is, explain what the difference is. If I give you something in words or in a graph, you need to be able to identify what type of motion it is. This idea of comparing and contrasting constant velocity and constant acceleration, also a really good question, probably going to show up on that test, at least for somebody. So make sure you know how to answer that as well. And again, you've probably already seen this question on homework. These graph relationships, you need to know what type of graph belongs to what type of motion. You don't need to have this memorized necessarily, because if you know the definitions, it should just kind of logically follow. So constant velocity, for instance, we know that would be horizontal, so we know that this graph would be a constant velocity graph. Whereas constant acceleration, remember, is that change in velocity. So if velocity is changing, that's a clue it's acceleration. If it curves, that's a clue and it's a distance graph. That's also constant acceleration. And then, of course, constant meaning horizontal acceleration, it will be a horizontal line for the acceleration graph. Okay, so just knowing these relationships is really helpful. I also think another key thing to know, if we go from distance to velocity to acceleration from these graphs, if I want to go this direction from distance to velocity acceleration, I look at slope. And if I go the reverse direction, I look at area. And I'll explain that a little bit more in the following lessons. So here we go. This is where we really got into the heart of graphing, constant velocity. Again, you should know that this would have, a line like that for its position, a horizontal line for the velocity, and then, of course, 0 acceleration, because it's constantly moving at the same rate, so it's not speeding up, it's not slowing down. And then if we had constant acceleration, the position graph is going to be some kind of curve, and then linear for the velocity graph, and then the acceleration is going to be, in this case it would be at 12, but a horizontal line. So this lesson was mostly just focusing on those relationships and knowing how to fill out the tables. So make sure you know how to do that. If it's constant, that means it remains the same all the way across, so it doesn't start at 0 here. I think that was a common mistake on a lot of the quizzes. People would put 0 even though it was constant. It starts right away moving at that acceleration rates. And then we did some practice problems, so that would be worth kind of reviewing those in your notes. Area under the curve. So this was the idea that if we go this direction from acceleration to velocity or velocity to distance, we look at area. So we did that with coloring in the graphs, remember? Where you picked a marker and like shaded the area under the curve and then calculated it. And we did all that to prove that really doing that area under the curve is this equation here that I highlighted in yellow. And this equation is in the reference table, but this equation just didn't drop out of the sky. It came from that area under the curve idea. So the purpose of this lesson was to show the relationship of area and how it gets you this equation. And then we spent a lot of time just reviewing. So this lesson was just reviewing the ideas we had learned up at this point. So again, the slope of a distance time graph gives you velocity. The slope of a velocity time graph gives you acceleration. And the area under velocity time graph gives you distance. Okay? You don't necessarily need to have these memorized, but you do need to know these relationships. So however you want to remember it, that's going to be really helpful for you. So the rest of that lesson was just, analyzing graphs. This type of graph, which is also, by the way, the answer to this question, but you should know how to analyze this type of graph. This is a really good one that I might ask you questions on. So making sure you know what this type of graph means. La 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 la, moving right along. Oh, but then we start to, I think this is the air resistance lesson. So the idea being here is that we say something's an air resistance to make the math easier for us. You need to know that a feather and a hammer, when dropped at atmospheric pressure, the feather falls last because of the air resistance, but if it's dropped in a vacuum, they will hit at the same time, which is super weird because we don't see that in our normal day life, but that's the way it works. So make sure you know that. So we talk about that. Oops, come back. All right, here we go. Talked about misconceptions. All right. Lesson 11 marks the end of the graphing section. This is when we were graphing the free fall motion. And this just slowly walked you through the displacement. What is the displacement, velocity, and does it have constant acceleration or not? So if I'm throwing a ball up into the air, the ball, when it gets to the top, is going to have a 0 velocity, and it is slowing down. And then when the ball comes back down, it is speeding up. So that you're going to need to be able to explain for velocity. For displacement, you would say it lands and starts at the same spot, so it would have a 0 meter displacement. So what does that mean for the acceleration? Well, it is slowing down, going to 0, and then speeding up. So that means the velocity is changing. So it's changing velocity, so that means it's a constant acceleration motion. And it's a constant acceleration motion because gravity causes it to slow down and then speed up, okay? So that's the reason why it's constant acceleration. And then we did an activity where we graphed this. So the distance graph looked like this. So this would be distance on time. The velocity graph, actually I'm going to make this 0 here. The velocity graph looked like that. And the acceleration graph, of course, was just a horizontal line. So yeah, then we filled out these tables, if you remember. And then we made that graph. And I asked you various questions on it. Oh yeah, this is a good one because I think in every single class, this one really forced the group to think, and a lot of us still had questions with it. So if I had to guess, there's probably going to be a question like this in the form of true false, any of these types of questions could be asked. Maybe it's not going to be this type of graph. Maybe it's going to go all the way through. Maybe it might ask you to analyze this section of the graph, or this section of the graph, or this section of the graph, in which case all these different answers may change. So you might want to spend some time really thinking about the motion. I think a good strategy for this is put in words what's happening in the graph. So in this one, we see it starts with a positive velocity and it gets close to 0. So if it starts at like 10 and it gets close to 0, obviously the velocity is getting smaller, meaning it would be slowing down. But I think if you just put that in words, whether in writing or in your own head before you start answering questions, it's going to make life a little bit easier for you. So I would recommend doing that. Okay, then we get to lesson 12, which is where we learn the next 3 big equations in this unit. So this is V final, not squared, sorry, just V final equals V initial plus AT. So if there may be a word problem where you might need to use that equation to solve. This distance formula we used on a focus, you might need to use that equation to solve for something, or, the V final squared plus 2AD. So you need to know at what times is it appropriate for me to use any of these equations, and how do I solve with that equation once I have it, okay? So again, don't memorize these equations. They're in your reference table, but you need to know how to use them and know how to solve for them. And then these were practice questions based off those equations. One of my classes, we skipped this part in the interest of time. I might recommend you go back and solve these questions as part of your prep and review. Or, even if we did do it in class, it might be a good idea just to go back and do these questions again, just to make sure you're really understanding this. Lesson 13 is practice solving word problems. So I gave you a really nice setup for these word problems when we were learning how to do it, in terms of list the relevant information, the variables, the equation, and solving and justifying. But I'm probably not going to do that on the test. I'm probably only going to give you literally the problem. That's it. Okay? So if you like this setup, you might have to set it up like this on your own, which I recommend doing. So same thing, I'll only give you the word problem, not the is this constant acceleration or constant velocity? Oh, what are your variables? I'm just going to ask you to solve. So make sure you're feeling comfortable with word problems. Again, a good strategy I like to have is underlining all the numbers that are given, and then circling what it's asking for. So in this case, it's asking for length, which we know is a distance. And then we know that this would be acceleration, and this is the takeoff speed, so that's V final. And then from there, you can kind of figure out which equation to use. So more equations. Lesson 14, more practice with equations. Sometimes there's word clues. Like if it says from rest, that means it starts at 0. If it says comes to rest, that means V final goes to 0. So just knowing things like that can be really helpful when you're solving these word problems. So more word problems. This one was a 2-step one. It was pretty tricky. I'm not going to ask a 2-step kinematics equation problem on the test, at least for what's required. Maybe for extra credit I might, but we'll see. All right, then we got into the idea of having horizontal components and vertical components of a vector, usually like a velocity vector. So we learned 2 more equations. We learned that this is a sin theta and this is a cosine theta. And this tells us the horizontal component of the leg, and this tells us the vertical component of the leg, and this is the initial vector quantity. So this could be something in meters per second, it could be something in newtons, it could be an acceleration, it could be a distance, any vector quantity it could be if it has an angle and is at some magnitude. So you will get a question on the test with these equations, so you should know how to use them. Make sure your calculator is in degree mode, because it's really sad when you solve these equations correctly, but your calculator's in radians, and then you get the question wrong. So if you have your own calculator, make sure it's in degrees for this test. Otherwise, if you're just using the scientific calculators, they should already be in degrees from my classroom. All right, these are examples of word problems that you might see on the test. Really good ones to make sure you know how to solve. Then we get into projectile motion. We did an activity with coin going off the table. Here's a picture. The vertical component, the vertical velocity increases with time due to gravity, and the horizontal is at constant velocity. So that's really confusing for a lot of students. You have to think of the vector. It travels this path, but within that path, you notice that the vertical vector is getting longer, and that's due to gravity, like I said, whereas the horizontal component is just moving a steady space at a constant velocity. So you have to think of it as two different velocities coming together to make this curve. So that's the main idea with that. I might read some parts of chapter 5 that explains this again, just because I know it can be kind of a confusing topic for students. Oh, then the relationships, this is related to lab. You know, different people did different experiments in lab, but you were supposed to share with your tables what your results were. So these questions here, these are good conceptual questions on projectile motion. So in this example, like the higher it goes, the higher the angle, the higher up the vertical height is, and at 45 degrees is when it goes the furthest horizontal distance. So those are some like relationships you might need to know. The shoot the monkey problem. Love this problem. I don't think I need to go over it in detail here. It's just an interesting problem that demonstrates this idea of two vectors in projectile motion, a vertical and a horizontal, and where you should aim the monkey cannon to shoot him a banana. Okay, so that's pretty much it in terms of what you need to know. So a good thing for reflection is, what topics on this unit are you feeling confident in? Is it the graphs? Is it the problem solving with equations? Is it describing motion in words? Such as, you know, the idea of constant velocity or acceleration. Are you able to describe that in words? Yeah, which of these things are you feeling pretty strong in? Maybe it's those focus activities that we do every day. Maybe you feel really good at that. Maybe there will be some of those on the test. But yeah, that's basically what this test is going to be on. It's going to be on graphs. It's going to be on problem solving with the equations, and then like describing the motion. Is this constant velocity or constant acceleration? How do you know? Some other really good tips for studying. This is what I would do all the time. Form a study group. 1 to 4 people. Maybe these are people in your advisory. Maybe this is your friends who are in this class. You know, and then hang out at someone's house and go over some of these problems together. Reading and answering those essential questions at the beginning, another great resource. Reviewing your notes, which we kind of just did here, except I just kind of like went through it very quickly. Redo problems you had difficulty in class. Labs, especially that PhET projectile motion lab, is going to be really helpful. And then this is a nice one. On the physics website, under the guided notes section, there's these equations that you should know. I mean, not equations, these numbers you should know. And then if you want like additional resources, the physics classroom has a lot of really good practice stuff there. So I want to really quick show you this. Let me see if I can do that real quickly. Gotta flip my iPad over. Let's see if I have my notes. Okay, here we go. So if you go to the guided notes section and it says review sheet for Regents physics, if you click on that, there's a ton of stuff. So I think I said you needed to know 1 through 12. So all of these things you should definitely know for sure. And then kinematics and motion, 1 through 25, 12 through 25. So all of these things, all of this stuff is stuff we've already just talked about. But if you want like a study guide, a study sheet of things you must know, this is the resource for you. Okay, well, I think that is really it for our notes and study tips. I hope this video has been helpful. And make sure you do that online practice quiz. It's not graded, but it's a great resource to inform you of what you need to work on to be a stronger physics student. All right, that is all for now. Have a good night.